Hi, guys. First off, before we start what we're doing today, I wanted to say that I was so excited to see some of you guys at my Google Meet yesterday. My Google Meets are optional, meaning you do not have to come. It also means if you have another Google Meet in a class, let's say like Mr. Darnold's class or Miss Hazlett's class, and it's mandatory, you have to go to theirs. After they're done, if you want to just pop into mine, I'm cool with that. Or if you'd rather meet me at a different time, I can set that up for you. If a class says it is a mandatory Google Meet, you need to go to that class. Please and thank you. Don't get me in trouble, kids. I put mine towards the end of the day because I think most of you are finally awake. So let's talk about what we're doing today. Today, we're going to talk about thermal energy. Maybe. Also, thank you for dealing with my technology problems. I'm not sure why that video did that. Was super happy about it doing that. It was great. So let's talk about this. Thermal energy. Thermal energy is the measure of all the energy in a system. It's based on the mass of the object, the temperature of the object, and the phase of the object. The phase is just if it's a solid or liquid or a gas. All three of these things together can change the thermal energy in an object. One of the big things with thermal energy and how part of it is calculated is through something called specific heat. It's the amount of heat needed to raise the temperature of a substance by 1 degree Celsius. It is different for every object. Usually what you'll see, you guys see up here, this big chart. If you ever get a chemistry book, like a big college chemistry book and look at it, usually at the back, they'll have this huge chart that's just full of these. These are specific heats of objects. What it shows is how much energy it takes to warm that object up. So things like aluminum. Aluminum is a metal. Metals are easily heated up, remember? They can conduct heat very well. And we'll talk more about that when we get to chemistry. But it only takes a little bit of energy for them to do that. Things like water, I know you can't see it because my arrow's there, but water has a very high specific heat. It's 4,181. That's kilograms per Kelvin. So it's a pretty high one. So is helium. Helium's a gas. Again, that phase where helium is a gas, it takes a lot more energy to heat up a gas. We're going to be using these as we go on to calculations today. Tomorrow you'll be practicing your calculations on these. And this one's a little bit harder than what we did yesterday. The lower the specific heat, the more temperature rises when energy is added. So let's say this. So you have a pot of boiling, looks like soup, whatever, probably should be water. You're adding heat to that. And you have a metal spoon and a wooden spoon. If they've been sitting in the heat the same amount of time, common sense says which one's going to be hotter? Your metal spoon. The wooden spoon, it takes a long time for wood to heat up, meaning it has a very high specific heat. Metals, just like if I go back, aluminum, they don't take as long to heat up, so they get really hot really fast. That's what specific heat is, seeing how fast things get hot. This is your equation. So everybody look at this before we do this math problem, okay? Do-do-do-do. Do-do-do-do. This right here, it says Q equals CM delta T. This thing is called a delta. It really just means change. So this delta T means change in temperature. The Q is the heat added. And isn't Q a weird one for that? It's because you can't really put like heat, H, because that looks like hydrogen, right? You got to pick a weird one, which is Q, equals C, specific heat, because it is a constant. It doesn't change. your mass, and then your change in temperature. So this is how your questions are going to read, okay? They're going to say things like this. How many joules of heat are removed from a 21-gram sample of water if it is cooled from 34 degrees Celsius to 28? So again, let's look at what we're looking for. How many joules, right? So you're looking for the energy, the heat added, because that's what that Q is, right? You have your specific heat. You're going to have to be given that. And for water, it's 4.18. And you'd be given that in your problems. Your mass, again, you're given that. And your change in temperature. When we want to find a change in a math class, we have to subtract it, right? That's what we're going to do. I will be honest with you. This math is a lot harder than what you did yesterday. So I expect to see a few more of you in my Google Meet that I have later today. Or excuse me, not today. That I have tomorrow for help for this, okay? Let's try one of these. So this is how you'd set it up. You're going to do Q equals, so that's what we're looking for. Then we have C. Again, you're going to be given this number in your problems. And then you have M. M is your mass. That's the 21 grams of the substance that you're trying to find. You then have your change in temperature. 34 minus 28, equals 6. This seems like a lot, but once you just plug that baby in to your equation, you're going to get 4.18, that's your C, times 21, that's your mass, right? Times, that's a 6 right there. It's behind my little arrow. Times 6, that's your change in temperature that you got from here, right? You're going to get 526.68 joules. Do not be upset if this is confusing to you guys. This is probably one of the harder math problems we do, just because it's weird variables and there's a lot of steps. So if you need help with this, please come to my Google Meet later. I will help you. The Google Meet I'm doing tomorrow, I'm going to go over a couple of the questions on your homework for tomorrow. Please attend that. I will help you. Okay, we're almost done. I'm going to go ahead and finish this up today, even though, because the rest of the stuff's kind of easy. This is something called a calorimeter. This is how we find specific heat. So what you do, this is called a coffee cup calorimeter. It sounds ghetto, but it works. Actually, it's very useful. You just have 2 coffee cups. You stack them on top of each other. You put a sample of whatever you're trying to get the specific heat of. You put it in water, and then you heat it up. You then time how long it takes for it to go up 1 degree. I hate the bells here. So if we were in class, I actually have a couple of these that I would show you. Maybe we'll get to it later. But for now, that's okay. The last thing is something called the laws of thermodynamics. This is the last part in our notes that I'm going to go over today, okay? Boop. So there are 3 laws of thermodynamics, okay? Thermodynamics is just how heat moves. Think thermo is heat, right? Dynamics is how things move. You're dynamic. You're very movable, right? There are just 3 laws. 3. 1 is energy is conserved. We've already talked about that one once, right? It's the law of conservation of energy. So we already got that one. Number 2, heat only travels from hot to cold objects due to work. This is how your fridge works. So your fridge does work, or it moves energy around to cool down your food. That's how a fridge works. A fridge actually takes energy from your warm food, and that's how it cools it down. The last one is something called absolute zero. And the 3rd law says absolute zero can never be reached. And that's because when you look at what absolute zero is, this is the last thing today, I promise. Absolute zero. Try again. Absolute zero is the lowest temperature that is theoretically possible. It is 0 Kelvin. It's theoretically possible because of this law. Absolute zero cannot be reached. And here's why. Water boils at 100 degrees Celsius, right? The human body natural temperature is about 37 degrees Celsius. Water is at 0 degrees Celsius. So water freezes, at 0 degrees Celsius. That's pretty cold, right? Absolute zero is negative 273 degrees Celsius. It is so cold, children, that literally the particles in your body, the little cells that, the mitochondria, that's the energy, the powerhouse of the cell, the only thing we ever remember from biology. It is so cold that those particles stop moving. And when they stop moving, nothing can exist. It's very weird. That's why it is a theoretical temperature. We can't measure that because if we did, the thing we're measuring with it would stop. And we'd be dead. So it is a theoretical. Okay, so that's all I have for you guys today. We will finish this up next. I can't make myself bigger. We'll finish this up next week. Tomorrow, let me show you guys what you'll be doing. Your homework looks like this. Sorry, I got to go to my drive. Thought I had it up. Oh, no. We are in chapter 16. So when you look at your modules, make sure you're in chapter 16. But notice the chapter 15 is still up. So if you're missing stuff from chapter 15, you should do that. Please do that. Where's that? Where did I put it? Okay. Your homework is going to look like this. It's going to have the equation. It's going to have what your unit is, joules. And then it's going to have some practice problems. There are only 5 of them. In my Google Meet that I have tomorrow, I will go over probably 2 or 3 of these, at least 2 of them. I don't know which ones yet, but I will show you how to do them if you come to that Google Meet. If you think you can do this and you're good to go, you can do it by yourself. You don't need me for the Google Meet. They are just like the ones we did yesterday, and also that we will give you the 4.18. I want to make sure that was in there. We'll give you the grams, the mass. I will give you the specific heat, and I will give you the temperature change. So it should be pretty simple if you know how to use this equation. If you're having problems, please come to my Google Meet. Google Meets are optional, and they're going to be at 1:30 to 2:30 tomorrow. Okay? If you pop in, I'm already working on one. Just jump in with us. Or if you have a question on one, I can help you with that. Okay? Cool? Okay, I hope to see you guys. Those of you who are going to need help tomorrow. If not, I will talk to you guys next week. Okay. Bye, guys.